This time, instead of defining the tasks, we will follow these steps. You will find in the exercise files an STP Security clean packet tracer file. I renamed it, saved it differently so that I don't mess up the original file, but we will be starting from the same file. The first thing we need to do is configure Rapid PVST on all switches. So let's do that. Next step is to configure access and port fast on access interfaces plus BPDU guard. Our access switches are these three switches, so switch 3, 4, and 5. And we only have one interface on this switch, that is an access port, but as all access ports in this exercise will belong to VLAN 1, we don't have any other VLANs defined. We don't really need to join this port into a specific VLAN. Also, we can skip the switch port mode access command. I will only type in the spanning tree port fast command, but first let's get into that interface, and then spanning tree port fast, and then spanning tree BPDU guard enable. We can do trunk at the same time while we are here. We will only have one trunk interface on this switch. So let's get into Fast Ethernet 0/23 switch port mode trunk. And then to switch 4, interface Fast Ethernet 0/1, spanning tree port fast, and then spanning tree BPDU guard enable. Here we will have two trunk interfaces, Fast Ethernet 0/23 and 24, switch port mode trunk. And we're done with switch 4. Let's move on to switch 5. Here, Fast Ethernet 0/1 will have spanning tree port fast enabled and BPDU guard. And then we will also have only one trunk interface, /24, switch port mode trunk. Let's configure the other trunk interfaces on other switches. On switch 1, it will be Fast Ethernet 0/23 and 24, switch port mode trunk. Gigabit Ethernet 0/1, also switch port mode trunk. And on switch 2, it's going to be pretty much the same interfaces, Gigabit Ethernet 0/1, switch port mode trunk, and then range F023-24, switch port mode trunk. That's it for access and trunk. Our next task is to configure root bridge. I've picked switch 1 to be root bridge for this VLAN, for the only VLAN we have here, VLAN 1. So the command is spanning tree VLAN 1 root primary, and then we will configure root guard or guard root on these two interfaces, on Fast Ethernet 0/23 and Fast Ethernet 0/24. That is because we don't want any of the access switches becoming root bridge. it is okay for switch 2 to become root bridge, and that is why we will not configure root guard on Gigabit Ethernet 0/1. The configuration is quite simple. We will get into the range of interfaces. So range fast Ethernet 0/23-24, spanning 3 guard routes. And guard root or root guard is now enabled. Now on to the test. First, we will test the BPDU guard on access switches, and the way to do this is to add a new switch into the network. Then I will delete this link between switch 3 and PCA, and then I will connect the new switch. Which port you use on the new switch doesn't really matter. It's important to use the Fast Ethernet 0/1 interface on switch 3 because that is the interface that has BPDU guard enabled. The link already got blocked, but we would like to see more information on that. So let's get into switch 3. We will see this warning here. BPDU guard error detected on 0/1, putting Fast Ethernet 0/1 in error disabled state. I'll use do show interfaces F0/1 to see more details. And in the very first line, we will see line protocol is down, error disabled. So this is what will happen if an attacker connects to your access switch and starts sending BPDU messages. Let me repeat here that no matter what kind of BPDU message an attacker sends, that port will be disabled. So that is BPDU guard. Root guard, on the other hand, will only block those ports where it receives a BPDU message saying that there is a switch in the network that has a lower priority than the root bridge. In order to enable this port again, first we will delete the link between the new switch and switch 3 and add a straight through cable or connection between switch 3 on Fast Ethernet 0/1 and PCA. As you can see, this link is still blocked, and the reason is that that port is pretty much switched off, so it can't really see any difference. It can't see any change. So what we will do is we will shut down that port and then switch it back on. That's interface Fast Ethernet 0/1, shut down, and then no shutdown. Do show interfaces F0/1. Fast Ethernet 0/1 is up, line protocol is up, connected, and we don't see any errors here, which is good. Okay, let's move on. To test the root guard configuration, we will try to configure switch 3 to become root bridge by lowering its priority. I'm going to get into switch 3 right away. Get out of the interface configuration mode. And first, I'm going to check what is the current root bridge's priority. I'm going to use the command do show spanning tree detail. I'm going to scroll up, and in the 4th row of this printout, I will see the current root priority. So the current root priority is 24,577. I will try to use the first lower priority that I can use, which is 4,096, lower than this one. The command is spanning tree VLAN 1, priority 20,480. And right away we should, or soon, we should see some activity here. That's right, we can see that this port on switch 1 went orange. So let's get into switch 1. And we will see this warning or a message saying root guard block port 0/23 tried to become non-designated in VLAN 1, moved to root inconsistent state. If I use do show spanning tree active, I will see that this bridge is still the root. Also, we can see that the port in question, Fast Ethernet 0/23, is in blocked state. To fix this, I will change the priority on switch 3. I'll try to go back to the default priority value, which is 32,768. As you can see, this port on switch 1 became green almost instantly. So in this case, that is all you need to do to unblock a port that was blocked by root guard. There you go. This is how STP Security works. We will be using it in our following exercises, but all that you really need to memorize are these two commands: spanning tree guard root and spanning tree BPDU enable.